All right. Hi, Sam.
Hi, how's it going?
It's going all right. How are you?
Good.
We just saw each other last night. We had a nice event at your place.
Yeah, that was very fun.
Yeah.
Thank you all for coming.
Cool. Okay, you mind if I ask the first question? Because since I'm a devoted Twitter follower of you, or X follower, whatever, you all know what I mean. I know I've seen a history of you claiming to be something of a MySQL fan, I would say, and so this latest change here, where a PlanetScale, which is renowned to be so good at MySQL, is now doing Postgres. It was surprising, I think, to a lot of people, right? So I wonder if you could dive in a little bit into why the sort of investment in Postgres after such a long sort of track record of being an advocate for MySQL instead.
Yeah, it was surprising to me as well, actually, when I first had those thoughts. I know I come across as someone who loves MySQL. Actually, I really hate MySQL. After spending my 20s fighting all of its scaling problems, I got good at knowing what it's bad at and what it's good at and what you can trust it for. The thing I really love is the system we've built on top of MySQL, which is Vitess. And Vitess truly knows all of the things MySQL does wrong and can kind of tank its inefficiencies and kind of do the right thing and get the MySQL cluster back into the state it's meant to be in. MySQL has been used around the world and at major companies like Dropbox, and we'll hear about your experience doing that, to build an older generation of the internet. When I was at GitHub, we'd get together at meetups like this with Facebook and Google and Yelp and Dropbox and Twitter. And it was just all of the kind of contemporary companies that were building Etsy. They were building interesting things. We're building them on MySQL. And kind of we came together to share the problems that we had with MySQL at scale. And we kind of got around those things, and MySQL matured. And now we want to do that for the Postgres world. We saw so much demand when we shipped PlanetScale Metal. I don't know if you saw that announcement, but we did a very simple announcement. We moved one of our customers that runs on our cloud, which is Cash App, which I'm sure there's plenty of Cash App users. Today we showed just a very simple example of migrating them to Metal and the performance improvements that kind of gave them. And we just got this crazy amount of companies coming in asking us just to do this for Postgres. And it was just so overwhelming. And I had this kind of nostalgic moment. I remembered this time at GitHub we migrated to Fastly, during an outage that Akamai had caused. And we were just crazy about it. We just aped in and just did it. And then I was watching, the night we shipped Metal, I was watching AI companies that were running on Postgres that had been going down on these other providers, were just migrating as fast as they can until 2 in the morning. So I remember that being that generation of company. And all the companies we work with at MySQL are much more established and running at absolutely gigantic scale. And I really saw this energy in the Postgres community that I remember from the GitHub days, and them wanting us to do something and work with them and bring something very mature to the market was extremely compelling. And yeah, we just, I walked over to Nick, who's here as our CTO, and this was at the Metal launch party. Mm-hmm. It's we have to do Postgres, and he just goes, it can't really be harder than anything else we've done. So it's yeah, we're going to do that. And so we started, and we really surprised ourselves. And I said this in the announcement post for Postgres, we had to know that we could do something different. And we were very quickly surprised how we could bring something differentiated. And so we have done that now, and it's been a fun journey. And part of that journey came by sitting in that room over there and saying, we're going to do this. You should join us in that mission. Mm-hmm. It's been just really fun so far. And it's just since the announcement, it's been absolutely just crazy. It's been wild.
Yep. Yeah. One of the things you mentioned at the beginning when you said I actually hate MySQL, right? I think maybe one interpretation of some of your objections in the past is the idea that one of these databases will magically solve anything is kind of the
right.
Databases are inherently very difficult to run and incredibly important, but also deeply flawed pieces of software. And neither MySQL nor Postgres is just going to magically be much better than the other one. And so I agree in terms of I too am is kind of ambivalent about these two databases. But the thing I'm very excited about is I'm excited about teams that know how to run them well, because that's really where the art is understanding the 40,000 things that go wrong and having both a game plan and a kind of orchestrational layer that can handle all those things, so that the sort of exterior experience for us using it is that it is effectively kind of seamless and flawless, because it is actually deeply flawed. So that's quite a magic trick to pull off.
And they're all deeply flawed,
Yeah,
right? And
they're all deeply flawed.
Every technology just sucks at scale. Like, it really does. It's just you choose the one that sucks less. And then when it does fail, which is like a when, right? Like, we have single PlanetScale customers with single databases that have thousands of machines in that one database cluster. That guarantees like daily failures, right? Mm-hmm. So if we're pretending it doesn't fail, we're going to like cause outages constantly. And so some people have said, oh, he really dislikes Postgres. Like, why would we accept PlanetScale into the Postgres community? And my kind of response to that is, I don't know if you'd go to a doctor that thinks we're magical and like infallible and can never get sick, or an airline mechanic that just thinks they're made of like magic and rainbows. Like, you just have to know the way planes fail over and over again, and just account for that time and time again. We're going to love Postgres as much as we love MySQL, which is we're going to figure out in every way it's going to do stupid stuff.
Yep. And
just figure those out. And then if you run through those scenarios enough times, you build something very robust. And that's the mission that we're on.
Something I'll observe, I didn't know about PlanetScale, but having operated these things myself in the past, I appreciated a lot right after we started using you, is that I realized that like when you all had things like configurations changed, like you all would use like failover mechanisms for everything, right? And like just to like share out with everybody listening and watching, for a lot of teams, failovers are really scary, right? Like if you just have one database, I mean, it's probably the most prudent plan is just kind of hope you never really have that server fail and just run it for a couple of years. And that's probably game theory what you should do. Like just hope for the best. And if you have a bad day, you bring it back up. And hopefully the failover works. But once you start getting into having thousands of these things and tens of thousands of these things, they're like, you're gonna tease out the long tail, and the thing that only happens once in a while starts to happen every day. And so I think by like embracing the worst case scenario, like meaning failover, by making failover just how you guys breathe, like breathe in, breathe out, it just ensures that like the worst moment is no worse than the average moment, right? And like to make a really reliable system, in my experience, that's the kind of DNA you need, is designed that way.
Yeah, and I don't think we've done enough talking about this, but you're completely right. Like if you have a very...
For a second, get you even closer.
Oh, pardon me, sorry.
Oh, is that, I need to be closer? Okay, yeah.
With PlanetScale Vitesse, and we're pretty much in the same place with Postgres as well. There's really only two ways to fix a problem. It's like an ERS or a PRS, which is like a planned reparent shard or an emergency reparent shard. Planned means we know it's going to happen, so the system has a heads up that that's going to happen, and so that's used for all types of upgrades. So every single node at PlanetScale is only 29 days old. There's not a single node in our infrastructure that lives longer than that. And if you think we're rolling through petabytes and petabytes and petabytes of state over and over again, that's a very elastic system, right? We achieve that by saying, like, if we want to upgrade MySQL, for example, well, we are just going to upgrade the replicas and just plan a reparent, and the parent of the new shard is the new primary, and it just rolls over, right? If we lose a primary, we do an emergency reparent. If we have a node that's just doing anything strange, we don't try to like introspect and like coddle that node and save it. We just kill it immediately. Like the first thing that happens is just kill that node. Mm-hmm. Vitesse has seen every kind of convergence scenario possible to get the node back to the cluster, back to the state it's meant to go in. And when you have those very simple ways of remediating all problems that just acknowledge and embrace failing nodes, killing nodes, you get to something like incredibly resilient. It's something we're very proud of. And it means that like when something we're not expecting happens, the entire company gets in. Like, you get a tiny issue on like even the smallest database we have, it being a novel way that we've never seen that failure condition before gets an incredible amount of attention. And it's kind of like the immune system. Like humans are incredible, like overcompensated. Like I don't know if people know. People talk about when you go to the gym, you get like newbie gains, right? Like your muscles grow really quickly. It's because your body just panics immediately. It's just like, that was insanely stressful. Like, I have to overcompensate for that.
Right.
If you treat like every issue your system has as something that will impact the immune system and inoculate against the next problem, you kind of just get this resilience and an abundance of that.
Yep. Yeah, maybe one way, like in my experience, to put that into practice is like, if we go back to that one database server scenario, like for that one database server, there's a chance that bad day you fail over will never happen, or if it does, the failover is fine. And so, but like if you have like 1,000 servers, like you're probably gonna, like the long tail of things that go wrong become less and less frequent, but like you're probably gonna hit one of the really bad ones eventually, because these systems, they still are pretty flawed actually. Like you would think, oh, failovers always work, and like the code paths are like, 3 states they can be in, but there's actually a ton of states they can be in. It gets pretty complicated. But if you have 1,000 database servers, you're gonna hit that eventually, but if you don't make failover part of your breathing, you're gonna hit it 15 months from now at 1 a.m. when half the people that were on the team that built that system aren't around anymore, and so it's gonna be like the really bad version of the bad day. Mm-hmm. But when you make it so that, hey, what we do every day is we just like use this muscle over and over again, there's a good chance you're gonna, and you have 10,000 things or 100,000 things, you're gonna hit it on day 4 when the team is still like, we're hardening this new system we built and everybody is fresh and on it, and then there's a really good chance there's not very many bad days ahead of you once you do that.
100%.
So
one thing I've realized is we were talking about scale a lot.
Yeah.
Part of the arguments I used to have with Postgres people on Twitter, and I realize you just never win, is because they work at a scale where anything will work. Mm-hmm. You've worked at massive scale.
Right.
Dropbox. Why don't you kind of tell us about what scale means to you?
Yeah, I mean, I think a lot, it does mean, like, my career was, I love startups, and so I worked in startups a lot. And a lot of times in startups, you spend a lot of your life in that one server, the black swan event never happens, like, at least in the early phases. And so I was very interested when I went to Dropbox, because the first project we did was building a new storage system to move Dropbox off of S3 and in-house. And so, and the goal was, do not ever lose a byte, like literally, never lose a byte. So, and the thing that terrified me about that is it felt like a difference of kind, not a difference of degree, because I'm like, I don't know how to make perfect software, so how do you make perfect software, right? And then while working there, you learn that, oh no, actually, like, things at scale is all about embracing how flawed things are, and then building layers of redundancy with non-overlapping seams so that you only permeate through like 2 of the failures at a time, 2 out of 5, right? And then if you do that externally, it looks like nothing ever goes wrong, but internally you've just built a machine that embraces failure and steers into failure. And so, and it's a lot of fucking work building those systems, right? To be honest. So it is, it has to be kind of worth it. But like when you're in one of those environments, you have real scale. A lot of times it's also like the stakes are high enough. It's kind of worth it to like, we need to make this thing run really, really well. And so yeah, to me, that was one of the biggest changes about scale thinking, was how do you like embrace things being flawed, and use the right sort of methodology around flawed things in order to make things that are, have the appearance of being quite close to perfect. Mm-hmm. And that was a really fun, skill to learn, I have to say, is like how to get good at that. So
it also really informs the product, right? Which is like, what can gray out when things go wrong, and have like a core user journey like actually work, right? Like the Amazon.com page basically just loads thousands and thousands of microservices,
right,
and just skips the ones that don't come back with an answer. Like if ads don't come back, then ads don't get loaded.
Right.
And it's very hard for people to understand how to build like product experiences where certain things go, really do fail. There's one thing that's worse than failure though, which is, because failure is kind of easy to debug, like the server's not responding. Slow is bad. Slow is way worse.
Yeah, slow.
You have a lot of opinions like how to avoid slow and what to do when things are going slow.
Yeah, well, I think, some of this is built into the way Convex is designed, right? Because like part of how Convex's goals really are to be able to allow more and more people to make great software without having a deep background in databases and stuff like this. And so one of the things you do learn at scale is that like, homogeneous loads are really, really good and heterogeneous loads are really bad. And so I think one of the bounding back pressure, bounding how long any operation can take, a few kind of decisions like that, as long as you're pretty consistent in making sure you apply them throughout your software, can be the things that help steer a system toward just failing instead of getting slow. And so a good example of that, like to make it concrete, is even though it's very annoying sometimes in Convex, you're not allowed to run a query more than a second right now. And for a lot of times, developers used to other systems come in and they say, well, that's really frustrating because like most of the time that's fine, but I've got this one page where I've got a dashboard and I just need to scan this whole table and do something. And Convex right now just won't let you do it. But the reasons for that are, this kind of a thing where like we want to be able to take you to scale, and things like that where like the more you can keep jobs where there are lots of small jobs is better than like a few really fast jobs and then some incredibly slow ones. It's very difficult to tune a system to be good at two different loads. I actually think one of the coolest systems that I feel like I learned a lot of lessons from in this world is like Erlang OTP, right? Which like you would take Erlang and you would run it against a lot of other languages and the benchmarks would be really bad, right? But then like running a service, it would be incredible. And part of why it would be incredible is like, I actually think the ecosystem has gotten better at this, but databases and everything else used to always publish benchmarks in requests per second, which is the most bullshit metric ever. Sorry if you guys have requests per second benchmarks. I think you have some, but you also say what the P99 is, right? Because in OLTP, like all that really matters is like how bad is the worst case or like the, close to the worst case, right? So, so you would rather take a service with like an 8 millisecond average, but like a 12 millisecond tail than something where the average is 4 milliseconds, but the tail is 6 seconds, right? Because if you really center these things in human terms, most humans can't tell the difference between 8 seconds and 4 seconds. And even if the query is 3 or 4 things together, it's still fine, right? But they definitely can tell the difference between 6 seconds and not 6 seconds. So
also when there's a massive outliers inside the P99, other systems then start to cascade fail.
Yeah, the back pressure pushes all the way through. Yeah.
So like our customers that have moved to Metal often report they now run less front ends.
Yeah.
Right, because they just need less things. Like everything is normally just like blocking on talking to the database. And when they get a much more consistent P99, it also helps prevent outages, right? Because like enough requests. I remember at GitHub in the early days of 2013, Twitter Bootstrap had like 60,000 stars, and then the next repo was like Rails with 10,000 stars. And you could denial of service GitHub by just people would write scripts to like scrape all of the stars, and they would hit Bootstrap, and it would just start going through like the 1,000 star page on Bootstrap there's all of the caches are cold. It's not in the database buffer pool. A couple of concurrent requests there can just block up every single front end on the website,
right,
and just crush everything. And that's just a very small amount of load entering the P99 and staying there.
Yep.
Just cascades failure around the entire website. So keeping it very predictable and having those bounds. That's why we kill queries at 20 seconds. We get exactly the same thing.
Right.
Eventually, this problem becomes wrong. And kind of going on systems, like building against systems that enforce these things very strictly as you do it, it's like baking your app into like a cake mold, right? Like it's going to just be shaped by the mold that it's in. If the mold has like very sensible defaults that come from just like a very good place.
Yeah.
Because like if you've got long-running transactions that are 20 seconds long, you are hurting every other system underneath. Like failovers are now harder. Schema changes are screwed because we're having to keep versions of snapshots of transactions. You're slowing down background threads. Like you just gum up your database really badly.
Right.
And then fixing those things once everything else relies on that is very, very difficult to go and do in retrospect.
Yeah.
You should just design around those things and then just know that like it protects the database, it's protecting itself.
Right.
As you do that.
Yeah, for sure. Yeah, we were just having a conversation a few minutes ago about like the concept of local reasoning, and it was like in a different context where it was related to LLMs and the way like Chef, our vibe coding tool, some of the ways it works. But those heterogeneous queries are actually a little related to like trying to maintain the virtues of local reasoning actually in a way, right? It's because like the more you sort of allow outliers, the more it may be this thing is affected by something that has nothing to do with it, right? And the problem you're most able to take action on is the thing you just wrote. And so the more you can eliminate that kind of thing, especially as teams grow and projects grow, like that's when it gets really complicated, like then you can just set yourself up to like, to have day 200 be about as good as day 2, right? And that's sort of that's the goal with something like Convex, but yeah.
We talk about like day 1,000 problems as well. Like,
Oh, you guys are at 1,000 already.
well,
Yeah, we're only at 200.
We're
so.
using much older technology. You're the cool stuff. But it's so funny what people optimize for, which is like how fast you can spin up a database. Like, we're going to do that once, but day 1,000 we're going to do things that can completely affect your business, and how serious those things are. I guess it's just what you optimize for, right? And like what the people building it care about.
Yep. Cool. Yeah. One thing actually, just to explain real quick, because like one of the it's not a question in the room right now, but it was a question on Twitter that a number of people asked is like, isn't Convex a database? And then why is Convex using a database, right? Like, so like a lot of systems are layered. Like there's a big system at Facebook called Tau, I think, that's it's built on MySQL, I think, and there was
largest graph database on Earth.
Yeah. So
MySQL.
Yeah, a lot of times databases are layered, and so Convex has always used a kind of traditional relational database under the covers. It's kind of where it records its journal of changes it makes, and so it's having a really good one of those has always been incredibly important to Convex being like a reliable, fast product. And we, like a lot of companies, we launched on AWS, and so therefore we used RDS and we used Aurora and things like that. But this was definitely one of the things where over time, it's, it is like the most important technology that underlies us. And so we kind of had our eye on PlanetScale for a while. We're kind of like looking for, I think, kind of an excuse, a reason to switch over. And a lot of why we're excited about this, both again because of the performance benefits, but also too because PlanetScale, to be frank, is pretty cost efficient as well. So like it both is a cost efficient way to store your data. It has incredible uptime, and it's fast as hell. And all those things are good. It has a great amplifying power in Convex because like Convex had kind of everything relies on that database under the covers. So when we make that better, the leverage for us is just so high because people's entire applications speed up. So we're very excited to be on it. But that's the sort of like, isn't Convex a database? Why is it using a database? Like the answer is yes to both. It is a database, but it also uses a database.
Yeah.
So
we also use other databases too. We use SQLite for certain things with Vitesse. It's that. Yeah.
Cool. One other thing I wanted to ask you, actually, this is another Twitter question, is I've noticed, there's a lot of Twitter questions, Sam. If you don't follow Sam on Twitter, you should, because Sam's a good follow.
I'm sorry if you
don't. And I'm not going to ask you if you're average database CEO. Okay, I won't. I'm just going to skate right past that.
A big fan.
I've noticed that like it seems to really upset you when the other database companies have outages and have large impacts on their customers, and like can you talk through? Maybe this is now a therapy session or something. It's like why do you get so upset about that situation?
Outages happen. I mean, they do happen, right? You can't they happen for everybody. You can't be mad at that on its own. I think it's more the frequency and the messaging of certain companies while they have that level of reliability. So at PlanetScale, we take what we do extremely serious, just extremely seriously. You can stop any piece of work happening at PlanetScale if it's going to affect reliability. It's like our craft. It's something that we're obsessed over. I mean, we spend so much time building a product and trying to make it reliable. And we try and do something that's very hard to do, but very boring. And the reason we talk obsessively about our customers is because we're proud of how boring what we do is for them so they can do cool things. So like every single human in this room interacted with a PlanetScale database today multiple times. You can't buy a coffee in America basically now without hitting a PlanetScale database. You can't send work messages. We have AAA rated games running on our platform. Like it's ubiquitous because of that job we do, and so people can do cool things. Anyway, I think every database provider should take that stuff really seriously, and some don't. And for years, I used to think it was terrible to talk about uptime, and at GitHub we just had a rule that you just don't talk about competitors that way. And we were the same until I kind of, there was